Okay, folks, we're going to talk about section 4-4, which is CPCTC. Now, you're going to find out what that means here in just a little bit, but today you're going to be able to determine the specific congruences and use that information to compute any valuable given the information. All right. And you see we're going to be using standards 2.2, 2.11, or 2.2, or 2.12. Sorry, I can't do numbers today. I'm only a math teacher. So, all right. Now, as far as the first homework quiz problem, I went ahead and did that for you, and I just matched up the like terms. We actually did this problem in a previous lesson, so you've seen how it works. It's just basically you find the parts that are congruent, set them equal, and solve. Now, this one's kind of more obvious. This one here is not so obvious, which is why I'm going to do this one with you. All right. So, I have triangle ABC is congruent to triangle DEF. Okay. Now, as we learned in previous statements, the corresponding parts will match in the congruent statement. Now, the congruent statement is right here. It's right there. So I know since AB is first and second, then I know that AB is going to match DE. So I got AB, which is 7. I got BC, which is 9. And I got AC down here, which is 11 plus X. All right. Now, I know that DF, which I have right here, is 3X minus 13. Let me rewrite that. And DE is 2Y minus 5. Now, we look at the diagram, but you got to look right here. And I want to show you right here. So AB is 7. And since AB is first, second, DE is going to match that because it's also first, second. So that's going to be 2Y minus 5, which I have right there. So I'm going to set those equal, and then we'll solve it. So I got 2Y minus 5 equals 7. So 2Y, add 5, you get equals 12. And then Y equals 6. All right. Now, the next thing we have is we have 11 plus X equals 3X minus 13. But why is that the case? Well, let's look. Because DF is first, last. AC is also first, last. So A matches with D, C matches with F. So therefore, these two are going to be equal, and I'm going to set them equal. So I got 11 plus X equals 3X minus 13. Remember, the diagrams help you, but what is important here is you have to see which matches right there in the congruent statement. That's what's most important. So I subtract X. So I got 11 equals 2X minus 13. And add 13, you get 24 equals 2X. So therefore, X equals 12. All right. Some basic algebra right there. All right. Now, so we got that. And we're going to talk about CPCTC in just a moment. But before we do that, let's do a review proof of what we discovered here earlier in the chapter. So we know that we're given. So the first statement here is going to be my given. Now, normally I like you to come up with your own statements. For right now, we're just trying to get through some of the basics here and trying to get you what you need to know. All right. Now, let's mark the diagram as we see it. So AB means that it is both parallel and congruent. So AB is parallel to DC, and AC is also congruent to DC, which we have them congruent there and parallel right there. So we got both of those, and that's part of our given. Now, the next thing it states is that angle 2 is congruent to angle 4. Well, why is angle 2 congruent to angle 4? Well, if you look, these lines are parallel, and these angles are congruent because, remember, they are alternate interior angles. They're alternate interior angles. Now, you're probably wondering, aren't 1 and 3 also alternate interior angles? Yes, they are. But we don't know that this line right there is parallel to that one. We don't know that. It doesn't say it. So we cannot state that angle 1 is congruent to angle 3 because of alternate interior angles. So if I write that right there, I'm going to write that, but And I'm going to put an X to it because we don't know. We don't know that they're congruent because we don't know if these two lines are parallel. All right. Then, of course, oh, I forgot to do this. I forgot. We're trying to prove that this triangle right here, ABD, is congruent to this triangle right there. I forgot to do that. I apologize for that, folks. But anyway, all right. So I'm trying to prove that the yellow triangle is congruent to the blue triangle. Well, what do we know about yellow and blue? Yellow and blue make green, and green is right there, AC. AC is congruent to itself by the reflexive property. And then I'm going to put a big two slashes to that. So why are these triangles congruent? That would be by side angle side. Side angle side is why those two triangles are congruent to one another. All right. Now, in the last two sections, 4.2 and 4.3, we've talked about proving triangles congruent by 3 steps. We proved 3 congruences. Well, in the first section, we had to prove 6 congruences. So that's, if you take 6 and subtract 3, you're going to have 3 left. There are still 3 congruences here that we can prove. But the question is, how do we prove those remaining parts congruent? That's what we're talking about today. And that is where the topic CPCTC stands for. It stands for the corresponding parts of congruent triangles are congruent. Now, here's the catch. You must prove the triangle's congruent before you can even use CPCTC. That's the abbreviation for it. Now I'm going to write it up here. CPCTC, which you have it right there as well. So good. But it stands for the following, and I'm going to highlight that in a different color. Corresponding parts of congruent triangles are congruent. It just basically says that the remaining parts are congruent. So let's look at this example down here. If triangle ABC is congruent to triangle XYZ by side angle side, or any other of the postulates and theorems, then the remaining angles and sides not used in the proof are congruent by CPCTC. So here's what it's stating. It's stating we said that these 2 sides are congruent, these 2 sides are congruent, and these 2 angles are congruent. But what we don't see is this, angle A. Angle A is congruent to angle S. Angle X, that is. Angle B, and that's supposed to be in blue. Angle B is congruent to angle Y. And AB is congruent to XY. Those 3 remaining parts are congruent because once we prove that the triangles are congruent, then all remaining parts that are corresponding after that are also going to be congruent to one another. So that's what CPCTC stands for. Okay, now I want you to look at the following proof right here. It says that AD is congruent to AB and AC bisects BD. So I'm going to mark this right here on my diagram. So AD is congruent to AB and AC bisects BD, and that is all the given. Okay. I'm trying to prove that this angle right here that I'm going to highlight in gray, angle D, is congruent to angle B. That's what I'm trying to prove. But actually, let's not do it that way. I like that purple. That way you see it better. Okay, I'm trying to prove that those 2 parts are congruent. That's what I'm trying to prove. But to do that, I must first prove that the 2 triangles are congruent. So I'm going to highlight this triangle right here in yellow, and that would be ACD, and this triangle in blue. So I'm trying to prove the triangle ACD is congruent to triangle ACB. So I'm trying to prove that those two triangles are congruent to one another. I have to prove the triangle's congruent before I can prove the remaining parts are congruent. All right. Now, I'm given that AC bisects BD. So that tells me that DC is congruent to BC, and that is by the definition of bisect. Now you could also use the definition of midpoint as well, because bisector is a midpoint when you're dealing with segments. Now it doesn't work with angles, but it does work with segments. But let's just stick with bisect. All right, now why is AC congruent to itself? Well, you learned early on that something is congruent to itself by the reflexive property. So, and I mark that as well. I always mark my. Okay, now you'll notice that we mark the diagram as we're going through it. That gives you a visual. And I keep talking about that in sections 4.2 and 4.3, but you have to have a visual. It's going to make things so much easier when you do that. And when we do that, you see that the three pairs of sides are congruent, so that means that the triangles are congruent by side, side, side. Okay, now we've proven that the triangles are congruent, but that's not what we're looking for. We're trying to prove that angle D is congruent to angle B. Well, how do we do that? Well, that is by what's called the corresponding parts of congruent triangles are congruent. CP/CTC for short. But the thing you have to remember is about this, you have to make sure that you prove the triangle's congruent before you can use that. I repeat that again. You cannot use CP/CTC until after you have proven the triangle's congruent. Now, I'll conclude this in part 2 of the video, which won't be very long because we're almost done, but I don't have enough time to finish it now.